sanity check. You have understood what map coloring problem is? If so, say yes in the chat window. Okay. And why you require variables for defining a state in a CSP problem. If that is also understood, please put yes in the chat window. It's a sincere request because that is how I'll understand whether you have come to the pace or not. Okay. Any simple thing, I'm missing that value. So I haven't done assignment. So if this is 1, 2, 3, fourth variable, and the fourth variable listed over here is New South Wales, it indicates that I have yet not chosen a color to color New South Wales region in the graph. Okay, I have selected colors for Western Australia, NT, Queensland, SA, and T. Sorry, yeah, whatever are the regions. So two regions I have not chosen the color for. Again, I have made a mistake. 1, 2, 3, 4, 5. This is the fifth one. 1, 2, 3, 4, 5, 6. Only 6 are there again. Okay, so this may be green. Just putting some value so that it looks like a state. Okay, so this is a state. There are 7 variables. These 2 variables, which are corresponding to these 1, 2, 3. So these 2 things. Okay, they are colors for these 2 regions. So Victoria region and South Australia region, I have not chosen any color for. Rest of the regions I have chosen color for. NA, not applicable. That is how in many Python APIs they represent missing values. Okay, NA. That is what that NA stands for. Anything else? Others have understood what exactly is going around? Nobody saying anything. Okay. People are saying yes. Good. Thank you. That letting me know that you are alive and I'm not talking just to the meeting. Okay. Let it be. It's a joke. Okay. So the constraint that in verbal form may be represented like this. Adjacent regions must have different colors. Constraint in a programmatic way or for a programming way should be, I will be checking certain equality, non-equality kind of thing for the certain variables. So my constraint will always be having one or more variables taking their part in defining them. So constraints are defined how? They are defined through different variables and certain conditions posed on the values that the variables can take. For instance, in this problem, the constraint is that no 2 adjacent regions must have same color. So I should, for every adjacent pair of regions, so how many pairs are there? There are a lot of pairs. This is 1 pair, this is 2nd pair, this is 3rd pair, this is 4th pair, this is 5th pair, 6th pair, 7th pair, 8th pair, 9th pair. At least 9 pairs I've figured it out. So every pair in this manner, I should check whether they have same color or not. So my constraint I can define as they are not having same color. That's the translation of English into the programming language. So WA should not be equal to NT. So WA not equal to NT. That is how the first constraint is defined. Or we should say that WANT in. So this is another way of defining the same constraint. So there are 2 ways. I should give you that insight as well. So one way to define a constraint would be, I should say that WA and NT should have different colors. So WA's value should not be equal to NT's value. One way. Another way, if I pair WA and NT as a tuple, so you know Python, you know what is a tuple. Tuple means 2 values together. Okay, so WA stands for color value of WA region, NT stands for color value of NT region. It should not be, or sorry, it should be in any one of these values. So it should be either red green, red blue, green red, green blue, blue red, blue green. So what we have done over here, we have done a cross product of domain of Western Australia against the domain of, so a bit of mathematics I have to give you that dose. So this is NT region. So domain of WA, cross domain of NT. So RGB, RGB. Okay, तीन दोनों जगह पे. So I just do a cross product of this. I'll get tuples. Okay, and I will remove all the tuples which are having same color value. So I'll remove red, red, green, green, blue, blue. These tuples I'll be removing. Okay, and the remaining tuples I can keep them because they satisfy the constraint. So the constraint can be represented in either a negative sense of it or a positive sense of it. Either valid possible colors ऐसे करके मैं उसको देख सकता हूँ. What are the valid possible combination to color Western Australia and NT's Northern Territory? So these 6, 1, 2, 3, 4, 5, 6 are the valid colors using which I can color them. This is one way of looking at the constraint definition. And the other way of looking at constraint definition, the formal definition is saying that WA and NT should be of different color. Okay, now how you implement it is up to you when you choose a particular algorithm. How an algorithm would find it good to test the goal test. Okay, that will be the way you will represent the constraint. Okay, please understand both way how you define these constraints. WA not equal to NT or WA comma NT in this particular set. Okay, both ways of definition will lead you to a different set of algorithmic solutions. Will lead you to different algorithmic solutions. Today we might not know, but later on we'll know. But important thing to note here is in both the ways, what we have done is we have actually used two variables in the definition of the constraint. So constraints are defined how? The constraint in a CSP problems, they are defined using combination of one or more variables and somehow they are joined with certain relational operators. Certain relational operators से उनको join किया जाता है. Okay. The second way is more mathematical way or a logical way, you should say, of representing the constraint. Whereas first way is more programming kind of a way, because in programming we have all these relational operators often used, and that's why we may often find WA not equal to NT better representation, because we are good at programming than thinking logically sometimes. Okay, not always, but sometimes that is the preferable way of representing. Now this is a discussion that I already did. So if you see this graph now, we have actually chosen certain colors for certain regions. So Western Australia is colored red, Queensland red, Victoria red, South Australia blue, Northern Territory, South Wales and Tasmania, they have chosen a color green for coloring. Now this is one kind of assignment to the variables. Now if you see, there were 7 variables and now I have all the variables instantiated in this particular state representation. So this state representation would be read as R comma, if that is the way I am numbering. So what was the way I was numbering them? It was 1, 2, 3, 4. Then this was 5. Sorry, 1, 2, 3, 4, 5 and 6. Okay, fine. So I'll just write the state definition as it would be in the program if I was writing this program. Okay. So I will have 6 things in as a set, or I could say it as a tuple. Tuple is a better representation. So I should say this is red, green, red, green, red. Then it's 5, 6 is blue, and 7 is green. Now this is the state representation for the given problem. So this is some state S for my problem, where I've chosen colors for every region. Now this particular assignment is referred to as a complete assignment because all 7 variables are instantiated. This assignment of values to the variables for the state variables is complete because every variable that defines the state is instantiated. Second thing, it is consistent because it does not violate any of the constraint of the given problem. That means every region is colored with one of the three colors that are given to us. I don't have any color other than that used. And second constraint was that no two adjacent regions are colored with same color. So you can visualize it and understand that yes, it is correct representation of, or the correct solution of the problem. And that is why I may have solution only if I have a complete assignment of values to variables. Okay, and I have a consistent assignment. So consistent assignment is an assignment of values to variables for a CSP where no constraint of the given problem is violated. Okay, so that's the two definition that you need to remember, or you need to understand if somebody asks how solutions to CSP achieved. Solutions to CSP are always complete assignment and consistent assignment. Complete assignment is the assignment of values to every state variable in the definition of state, and consistent assignment is that complete assignment. So consistent assignment need to be first, not necessarily always it should be complete, but consistent assignment can also be an incomplete one. I showed you one incomplete assignment already. Okay, so consistent assignment is that the one which does not violate any constraint of the problem. So I may have one region not colored. That means the assignment may not be complete, or it may be incomplete, that is what you should say, but it may be still consistent for all the rest of the variables. Okay, so it may be incomplete but consistent, and solutions are always complete and consistent. ये आपको याद रखना है.